What's in the warehouse this week? Hello and welcome to my very short overview of the Hoval TransTherm aqua hot water product. If you've got a couple of minutes, I'm going to try and explain how these units fit together with other bits of equipment and how they can be utilised with more efficient, low temperature, low carbon heat generators like condensing gas boilers or even heat pumps. Conventionally, if you're using a boiler or boilers like the ones over there, to make domestic hot water, there's no real effort to control heating supply temperatures. You simply take heating water from the boiler, typically at 70 to 80 degrees C, to the device that you're going to make the sanitary hot water in, and the focus in those devices is to make sure you've always got enough hot water for your needs at the right sort of temperature. The heating return temperature back to the boiler or the heat generator isn't really considered, and often it can be 60 degrees C or more. This isn't particularly helpful if you're hoping to get the most from a condensing gas boiler, or certainly even more importantly where you're trying to run it in a system that includes a heat pump. Because operating at those sort of water temperatures, or the heat pump may not even work, but it'll certainly work at a much lower efficiency, a lower COP, than might otherwise be the case if the water was a lot cooler. So the design intent of these devices, the TransTherm aqua units, is to take a heating supply at 65 or 70 degrees C from our heating device, and then utilise the temperature of the cold water main to drive the heating return back to our heat generators to something closer to 30 or 35 degrees C, while still making sufficient volumes of secondary water at the temperature it needs to be. We have two possible applications. So we can utilise the heating supply to make sanitary hot water on demand or on a continuous basis. That's in our TransTherm Aqua F. Or we can take a heating supply to make and then store sanitary water over an extended period of time using a TransTherm Aqua L and a suitable storage vessel. This is a charging solution. In both cases, the aim is to control the primary heating supply in such a way that we can take the supply of 65 or 70 degrees C from the boiler and or the heat pump, make sufficient hot water for our application, and then ensure that the heating equipment sees a return temperature that is as low as we can try and get, targeting 30 degrees C, certainly during periods of a high draw. Okay, having removed some of the casing and taken some of the internal insulation away, you can see that it's a relatively straightforward piece of equipment. In real life, when we're not in the warehouse, this would be hanging on a wall. And because it's a charging device, this is the TransTherm Aqua L, it would be adjacent to a stainless steel vessel. And we'd use this device to charge the vessel with secondary hot water, sanitary hot water, up to 60 or 65 degrees C. And so what you have to imagine, with a little bit of imagination, is that we have the cold water coming in at the bottom here and going into this, via this pump, into the heat exchanger, which is round on this side of the unit. The mains cold water comes in at the bottom, and when we get them to site, we'll mount a little commissioning or balancing valve on there to control a measured flow rate on the cold water side through the unit. Variable speed pump then will circulate the water via a non-return valve into the heat exchanger. There is an option at this point here to add some secondary recirculation. So if the site's circulating the secondary water around all the tapping devices, there's a possibility of fitting that in here. And then of course we have a safety valve on the unit which is just connected here, set to 10 bar. Across the other side of the heat exchanger, the heating supply and return, the bit we've talked about already, we've got initially that would enter through the bottom, and go back to the heat generator from the bottom as well. And we have a 3-port valve, a mixing valve, which is motorised, and then a high efficiency pump to have that circulation around the primary side of the heat exchanger. The heat exchanger, as I say, is bolted onto the sides. This is a wall mounted unit, and we do this from 50 kilowatt capacity up to around 275 kilowatt capacity. And obviously some of the components will change to suit the higher capacity units. So cold water in, and then we have at the top hot water going to our vessel, our charging vessel, our combi valve C actually, and of course that will then circulate round and can then come back in through the bottom as well. The controls and everything else are behind this side of the panel, and we normally have a touchscreen mounted in here, which we'll do when we get the unit onto site. Okay, primary side, we again would have to imagine connections coming from the boiler going in at the bottom, through the 3-port valve, and then through the pump, and then on to the plate heat exchanger, before going back down again and out to the return of the heat generator, the boiler or the heat pump. And again, that will have a commissioning or a balancing valve on it, so that the flow rates can be all set when we come to commission the equipment on the site. If we look now very quickly at the control side of it, it's all inbuilt into the unit. On the top here, we'd fit a touchscreen, an interface unit which sits in there. Obviously we don't want to put that on while we're transporting it, so it's in the box somewhere. Okay, but quick look behind here reveals the brains, if you will. We have a standard programmable piece of electronics which we parameterize when we set the thing up, along with a couple of sensors which will go into the storage vessel, and really that's about it. Okay, so as I said, there's a variety of different size heat exchangers and component parts. There's also a variety of vessel sizes as well. And what we do when we select a package for a customer is we look at what they want and we try and make sure that we match up the size of the unit, the size of the storage vessel to their demands. In conjunction with a wall-mounted unit with a TransTherm Aqua L, we always have a stainless steel vessel. I should have mentioned all of the parts on the secondary side, the sanitary hot water side, are made from materials like stainless steel or brass. So it's perfectly safe to use with sanitary water. But this is our combi valve C vessel, so it's basically a C1000, this one. So we'd be storing up to 1,000 litres of domestic hot water in here. And the reason why we charge it and store up to 1,000 litres is to meet a very high level of demand over a short period of time.